In this video, we will discuss about Wronskian. So, what is Wronskian? Okay. In the previous video, we have discussed about differential equation, and we have also discussed how to find out the solution of a given differential equation. So, why we will read Wronskian? Wronskians tell us about the nature of solution of differential equation. If you have a differential equation, suppose you have a second order differential equation, okay, second derivative of y with respect to x plus p, suppose first derivative of y with respect to x plus q into y, suppose equal to 0. So this is a given differential equation, and in this differential equation you have to find out the solution. Suppose there are two solutions of this differential equation. One solution, suppose say y1, another solution, suppose say y2. That means y1 and y2 are two solutions of the differential equation. Then if you find out the Wronskian, then this will tell you about the nature of solution in differential equation. What is the nature of solution of this differential equation? Nature means the solution of the differential equation, that is a function. What is a solution of differential equation? So solution of differential equation means the function of the equation. If you find out the function of this equation, that means you have to find out the integration. If you find out the integration of this differential equation, then that will be the solution or the function of differential equation. So Wronskian will tell you the solutions of this differential equation, whether they are linearly independent or linearly dependent. Whether the solutions are linearly independent, okay, are linearly independent or linearly dependent, okay, dependent. So if the solution, suppose y1 and y2, they are two solutions. If they are dependent, then Wronskian will be equal to 0. If Wronskian will be equal to 0, then the solutions of the differential equation, that is y1 and y2, they are linearly independent. Okay. If Wronskian is not equal to 0, if Wronskian is not equal to 0, then the solutions of this linear differential equation, suppose y1 and y2, they are linearly independent. Okay. So Wronskian will tell you whether the solutions of the differential equation, they are linearly independent or they are linearly dependent. Okay. That is why we read Wronskian. If Wronskian is equal to 0, then the solution of the differential equation are linearly dependent. And if Wronskian is not equal to 0, then the solution of the differential equation, they are linearly independent. That is why we read Wronskian. So if in the examination question will come, what is Wronskian, then we will write like this: Wronskian tell us about the nature of solutions in differential equation. That is, the solutions of differential equation or the function is linearly independent or linearly dependent. Wronskian will tell you what will be the nature of the solution in differential equation. If Wronskian is not equal to 0, then the solutions of the differential equation are linearly independent. And if Wronskian is equal to 0, then the solutions of differential equation are linearly dependent. So this will be answer for the question, what is Wronskian? Then next question is, how will find out the Wronskian of a given differential equation? Suppose you have a differential equation, second derivative of y with respect to x plus p dy by dx plus q into y equal to 0. This is a second order differential equation. Suppose the two solutions of the differential equations are y1 and y2. Then what will be the Wronskian of y1 and y2? Wronskian, that is written as w y1 y2, that will be equal to the determinant of y1 y2, then y1 first derivative, y2 first derivative. So this will give you, the determinant will give you the Wronskian of the differential equation. In this way you can find out the Wronskian of the given differential equation. So in the examination question will come like this. How we'll find out the Wronskian of a given differential equation? You write like this. Let y1 and y2 are solutions of a given second order differential linear homogeneous differential equation, like in this form. Then the Wronskian of the given differential equation, that is y1 and y2, that will be equal to w y1 y2, and the determinant of y1 y2 y1 dash y2 dash, that is the first derivative of y1 and second first derivative of y2. Let us work out a problem. Suppose you are given the solution, two solutions of a given differential equation. The first solution is y1, suppose equal to cos omega x, and another solution y2 is equal to suppose sin omega x. So two solutions of a given differential equation are given. Okay, suppose these are two solutions. These are solutions of the differential equation. Suppose say second derivative of y with respect to x plus omega square y equal to 0. And you find out the Wronskian of these two solutions. This is the given differential equation, well known differential equation. Okay, and if you have to find out the Wronskian, then what will be the Wronskian? Wronskian y1 y2 will be equal to determinant of how much? y1 y2, then first derivative of y1, then first derivative of y2. That will be equal to how much? Cos omega x sin omega x. Then what will be the derivative of cos omega x? Minus omega sin omega x, and the first derivative of sin omega x, this will be equal to omega cos omega x, then determinant. Okay, and this will be equal to omega cos square omega x plus omega sin square omega x. And if you take omega common, then in the bracket you have cos square omega x plus sin square omega x. Okay, and sin square omega x plus cos square omega x, this will be equal to 1. So this will be equal to omega. So you see the Wronskian, this is not equal to 0. Okay, the Wronskian is not equal to 0, and I have told you, if Wronskian is not equal to 0, then